Okay, we're going to go ahead and get started. Thank you for joining us, and welcome to our webinar entitled Combating the Workforce Shortage with CAM Automation. My name is Mark Bissell, and I'm a Senior Application Specialist for HCL Technologies, the makers of SOLIDWORKS CAM and HCL CAMWorks. We have a lot to cover today, and only a limited amount of time, so let's go ahead and get started. The format for this webinar is straightforward. If you get interrupted, no problem. Following this webinar, we'll send all those who registered a link to a recording of the webinar for you to replay and review at your own pace. There are far too many of you in attendance to unmute everyone. The background noise alone would make it difficult to hear. But following the webinar, we'll have a question and answer session. So as we're going along, please feel free to type in any questions you might have, and I'll answer as many as possible during the Q&A session. Following the webinar, if you'd like to get more information regarding the technology and solutions we'll be discussing, go to www.camworks.com and you'll find a wealth of information, including videos and more. Let's begin by discussing the new normal and how the pandemic has affected the world we live in, and specifically the effect the pandemic has had on the manufacturing industry. Even before the pandemic, many manufacturing firms had trouble finding qualified candidates. According to a survey in 2019 by the Workforce Institute at UKG, 38% of manufacturers were having trouble finding qualified candidates to fill the positions they had open. And since the pandemic, that number has grown to 54%. In addition, nearly 2/3, or 63%, of companies reported they are having difficulty filling labor gaps, and almost a quarter reported they are really struggling to fill their shortages. It seems, particularly in manufacturing, there are far more jobs available than there are workers to fill them. For a number of reasons, many related to the pandemic, workers are resistant or at least slow to return to work. So how is this skilled labor gap shortage impacting the manufacturing industry? The short answer is severely. For example, in the U.S., the economy is recovering and many manufacturing firms are seeing an increase in the number of orders. But due to the shortage in skilled labor, production is still down and companies are struggling to keep up with the increase in demand. In addition, the pandemic and skilled labor shortage has severely impacted the supply chain, and this has affected many manufacturers on both sides of the value stream. On one end, the raw materials and purchased goods manufacturers need to produce products are in short supply, and the supply chain disruptions are causing delays. While on the other end, if and when they are able to produce the products on time, the supply chain disruptions often still result in late deliveries. To make matters worse, the high demand and limited supply of workers means higher competition for those that are available. For many manufacturing firms, the skilled labor shortage combined with the supply chain disruptions are a double whammy, leaving them between a rock and a hard spot. So what's the solution? How are manufacturing companies and suppliers coping with the new normal of both a shortage in skilled labor and supply chain disruptions? And why is it that some companies are thriving while many others are struggling? First, consider the fact that businesses that were well along the road to digital enterprises were able to quickly adjust to working remotely, and as we come out of the pandemic, these companies are faring much better than those using more traditional business models. In short, the pandemic has helped manufacturing companies become keenly aware of the importance of digitally transforming their businesses. The same can be said for smart manufacturing and Industry 4.0 automation. Manufacturing firms which had gone paperless and were already using smart manufacturing automation tools before the pandemic were in a much better position to minimize the impact on production and pivot to working remotely. Going forward, it's clear smart manufacturing and Industry 4.0 can help companies to automate the design through manufacturing process, and by using these strategies, manufacturing firms can leverage their existing labor force to combat the shortage of skilled labor. We here at HCL are dedicated to providing cutting-edge software solutions to help the manufacturing industry leverage the existing workforce, increase production, reduce cost, and improve quality. So next, let's review some of the tools available to help manufacturers, both small and large, combat the skilled workforce shortage. To begin, fully integrated CAD/CAM is an ideal solution to help fill the skills gap. For example, when using SOLIDWORKS and CAMWorks, the CAD and CAM model become one and the same, and all of the CAD and CAM data is stored in a single file. There's no need to maintain separate CAD and CAM files, and there's no risk of machining an obsolete revision of the part. In addition, the toolpaths are fully associative to the design model and update automatically to design changes, saving you valuable time and effort each time an engineering design change occurs. And perhaps most importantly, once CAMWorks has been configured, engineers and designers who are skilled SOLIDWORKS users can also take on some of the CNC programming responsibilities in order to fill the skills gap. Another automation tool SOLIDWORKS CAM and CAMWorks offers is feature-based machining. Similar to feature-based design using SOLIDWORKS, utilizing SOLIDWORKS CAM and CAMWorks, you can easily create parametric machinable features that are fully associative to the design model. The end result is an 80 to 90% reduction in programming time as opposed to traditional standalone CAM systems. I might also mention SOLIDWORKS CAM and CAMWorks are both developed by HCL. SOLIDWORKS CAM is included in every seat of SOLIDWORKS 2018 or later currently on subscription, and CAMWorks extends SOLIDWORKS manufacturing capabilities to enable SOLIDWORKS users to program more complex CNC machines. And all of the CAM data is fully compatible between SOLIDWORKS CAM and CAMWorks. This means engineers and designers currently using SOLIDWORKS already have a robust CAM system at their disposal to assist in creating CNC programs to help fill the skills gap. From their inception, SOLIDWORKS CAM and CAMWorks included exceptional tools for automation. Using proprietary feature recognition technology, over 20 different types of machinable features can be recognized and added to the feature tree automatically. Another unique automation tool is knowledge-based machining, or KBM. Using KBM, companies can capture the best practices of their best machinists and programmers into a company-owned database and reuse them automatically. Thanks to KBM, SOLIDWORKS CAM and CAMWorks enables companies to standardize their tooling and processes, create a library of machining strategies, and automate their CNC programming process. Given the current shortage of skilled labor, these automation tools are more important than ever because they help companies empower their existing labor force to do much more in far less time. Using these smart manufacturing tools, CNC programs that took hours can be generated in minutes and even seconds through automation. And the programs generated are more consistent, promote standardization, and can be optimized to reduce costs and improve quality. To enable the use of digital twins for smart manufacturing and Industry 4.0, HCL developed a technology called tolerance-based machining, or TBM. TBM reads SOLIDWORKS MBD data and automatically selects the correct machining strategies to meet the tolerance and surface finish requirements. GD&T, ISO 286, and surface finish symbols can all be used to automatically select machining strategies. This cutting-edge technology leverages digital manufacturing to automate the CNC programming process and optimize the machining process. Another great tool in our arsenal for combating the skilled worker shortage is CAMWorks Virtual Machine. CAMWorks Virtual Machine leverages true G-code machine simulation to help you virtually prove out your CNC programs and cut setup times by 50% or more. CAMWorks Virtual Machine includes collision detection for machine components, work-holding devices, and tools to enable companies to avoid costly collisions, broken tools, and reduce downtime. CAMWorks Virtual Machine is another ideal solution for combating the workforce shortage because it allows companies to prove out CNC programs remotely without using machine time. And shorter setup times, along with shorter cycle times, means shorter lead times and quicker deliveries. Next, let's take a look at some of the smart manufacturing tools we've discussed in action.
Here's a part model designed using SOLIDWORKS. The intent is to machine the part from 6061 aluminum. This part will require 7 setups on a 3-axis CNC machine, or using a 5-axis CNC, this part could be machined in a single setup using indexing or 3+2 machining. Let's use the integrated SOLIDWORKS CAM by CAMWorks to program this part. I'll begin by extracting the machinable features on the part model. SOLIDWORKS CAM can automatically recognize over 20 different types of machinable features and add them automatically to the feature tree. Here you can see all 7 setups have been created, and the features from each setup have been recognized and automatically placed under each setup in the SOLIDWORKS CAM feature tree. Next, I'll generate the operation plan, and SOLIDWORKS CAM will automatically generate all of the operations required to machine the features using knowledge-based machining. All of the operations are now created and have been added to the SOLIDWORKS CAM operations tree. Next, we can generate the toolpaths for the operations, and all of the toolpaths are created automatically. Each operation can be opened and reviewed. Any desired changes can be made to the operation parameters and saved back to the database, so the next time the operation is generated, it will include any desired changes. Now that all the features and operations have been generated, we can use Toolpath Simulation to simulate the machining of the part. SOLIDWORKS CAM Simulation displays each of the operations that will occur on the CNC machine in the order listed on the operations tree and performs collision detection on the tool, tool holder, and stock. Once the simulation is complete, I can use the Compare feature to compare the machined model to the design model for accuracy. I can see the part has been completely machined except for the surfaces in the center of the part, which will program automatically later using tolerance-based machining. Now that the part has been programmed, I can post-process the data and generate the G-code program required to machine the part on the CNC machine. I'll give the file a name and then generate the G-code for machining. Here you can see the G-code program being post-processed. Next, let's take a look at the tolerance-based machining, or TBM automation, included in every seat of SOLIDWORKS CAM. We'll begin by setting a tolerance range from 0 to 0.1 millimeters for whole features and select a precision machining strategy for the MBD tolerance range. Using TBM, Users can define multiple tolerance ranges for different types of features and select the machining strategies required to meet the tolerances specified by the MBD data. On the Surface Finish tab, we can assign a color to each surface finish range, and the color will be assigned to each surface that falls within the specific range. We can also assign the correct machining strategy to meet the surface finish requirements when TBM recognizes each surface finish symbol. Next, we'll use automatic feature recognition to extract the machinable features on the part, and TBM will read the MBD data and assign each of the colors and machining strategies we specified under the TBM settings. Now we'll generate the operations for machining using knowledge-based machining, and thanks to TBM, the assigned strategies will create the operations required to meet the tolerances and surface finishes specified by the MBD data. Now that all the operations have been generated, we can generate the toolpaths for machining. Once all the operations have been generated, we can use the integrated simulation to verify the toolpaths for machining. Here you can see the simulation of each of the surfaces being machined. And when the simulation is complete, we can use the compare feature to compare the machined model against the design model to see that everything is completely machined. Once we're happy with the machining process, we can generate the G-code for the CNC machine to machine the part. I hope you're beginning to understand how MBD data and tolerance-based machining can help you reduce programming time and improve the quality of your parts. And when you're ready to move to the next level, CAMWorks can be used to program even the most complex parts, including 3-axis molds and more. Here, using CAMWorks, a 3-axis mold for a PVC fitting is programmed in less than 5 minutes. And when a change to the inlet dimension of the part from 30 millimeters to 25 millimeters occurs, the mold updates automatically. Because the CAD and CAM files are one and the same, CAMWorks recognizes a change in the mold has occurred, and the fully associative toolpaths are automatically regenerated. Within seconds, the toolpaths are updated, and a new CNC program can be created for the new revision of the part. Using CAMWorks, even the most complex parts on the most complex mill turn machines can be programmed easily. CAMWorks can take advantage of the full capabilities of your machine so you can get the most out of your investment. Even the most complex 5-axis parts can be programmed using CAMWorks. Impellers, blisks, ports on cylinder heads, and more can all be programmed. And using CAMWorks Virtual Machine, you can leverage true G-code simulation to prove out your programs and reduce setup time. And perhaps most importantly, during this time of crisis with COVID-19, SOLIDWORKS, CAMWorks, and CAMWorks Virtual Machine enable the designer, CNC programmer, and CNC machinist to all work remotely and seamlessly so production can continue.
Now that we've reviewed some of the tools available for automation, let's discuss some of the smart manufacturing tools available for optimization. CAMWorks VoluMill is an ultra-high-speed rough milling technology to help reduce cycle times by 80% or more and increase tool life by as much as 500%. As a result, using VoluMill, companies can increase production by as much as 400% using their existing machines and machinists. In a similar way, prime turning by Sandvik has now been added to CAMWorks to allow for a 2 to 3 times increase in feeds and speeds for turning, while at the same time providing a 500% increase in insert life. Optimization technologies like VoluMill and prime turning are a great way to combat the workforce shortage. Companies often see a 2 to 4 times increase in production using their existing machinery and personnel. And greatly reduced cycle times means parts can be machined far more quickly, making it easier to ship earlier and supply on-time deliveries even with supply line disruptions. Now that we've looked at some of the tools for automation, verification, and optimization, let's look at a new tool created to improve communication. CAMWorks' new shop floor is a digital communication tool specially designed for paperless manufacturing. CAMWorks Shop Floor is an easy-to-use app for use on the shop floor by CNC machinists and operators to move CAD/CAM out of the office and onto the shop floor for a fraction of the price of a full CAD/CAM system. Let's watch a short video to learn more.
CAMWorks Shop Floor is a new, affordable, smart manufacturing product designed specifically for use on the shop floor. All of the CAD and CAM data necessary to manufacture a part can be provided to the shop floor in a single digital file. Out on the shop floor, a CNC machinist or inspector can open the file, and CAMWorks Shop Floor provides a robust set of tools to view, measure, and section solid models. All of the CAM data, along with digital setup sheets, tool list, and the G-code program, can be displayed to assist in the setup of the CNC machine. The CNC program can be simulated using state-of-the-art Toolpaths simulation and step-through simulation to allow the user to review each move of the CNC program. An NC editor powered by Simco is also included to allow the machinist to review the CNC program, backplot directly from the G-code, make any final changes, and send the program to the CNC machine. CAMWorks Shop Floor provides file tracking capabilities to warn the user if a change to either the CAD or CAM data has occurred to avoid an outdated revision of the part from being manufactured on the shop floor. The ability to display, search, and filter MBD and PMI dimensions and data is included to allow the use of fully dimensioned solid models, eliminating the need for 2D drawings when you're ready to take your company to the next level. Never before has such a powerful set of smart manufacturing and Industry 4.0 tools been available on the shop floor, and the ability to publish shop floor files will be available to all SOLIDWORKS CAM and CAMWorks users. Using CAMWorks Shop Floor, you can reduce setup times, avoid costly collisions, improve quality, increase production, cut your delivery time, and take CAD/CAM out onto the shop floor for a fraction of the cost of a full CAD/CAM system. Bring your shop into the 21st century with CAMWorks Shop Floor.
So if your current workflow is being disrupted by skilled workforce shortages, or you're experiencing supply chain disruptions that are making it difficult for you to meet production demands and make on-time deliveries, consider how the tools we've discussed can help you improve your workflow. By leveraging the latest automation, optimization, verification, and communication tools, you can come out a winner in the battle against the workforce shortages and supply chain disruptions that have become the new normal. Leveraging the latest technology, you can reskill your workers and get the most out of the employees you have available. Using smart manufacturing, you can fill the skilled workers gap and significantly increase your production with your existing workforce and machinery. These cutting-edge tools can help you accelerate your time to market and digitally transform your workflow so you can increase production, reduce costs, improve quality, and make on-time deliveries. The well-known businesswoman and Shark Tank TV star Barbara Corcoran once said, "Procrastination is the enemy of success." So consider this a call to action. There are those things which are out of our control, but if we expect to succeed, we need to have the courage to change the things we can. So I would encourage those listening not to continue to procrastinate, and instead Use this webinar as an opportunity to take action and invest in the technologies that will help you combat the workforce shortages and supply chain disruptions and determine the industry leaders of tomorrow.